children, welcome back to video lessons. In this class, we will learn about Pythagoras theorem. In the previous classes, you have come across Thales theorem, A criteria theorem, then the third one, areas of similar triangles. Theorem based on areas of similar triangles. So today we shall learn about Pythagoras theorem. So here on the board we have a right angled triangle ABC, right angled at the vertex B. I have drawn squares on the sides AB, BC and AC, squares. And you know, the side opposite to the right angled vertex in a right angled triangle is called the hypotenuse. So AC is the hypotenuse. These are the other two sides of the right angled triangle ABC. I have also divided the squares on all the three sides of the triangle into unit squares. Here on AB, the square is divided into 1, 2, 3, 1, 2, 3. So 3 3s are 9 unit squares. You can just count it and make it clear. On the side BC, I have made 4 unit squares on the side BC and here also 4. So 4 4s are 16 squares. So this is 9 square units or else unit squares. And here you have 1, 2, 3, 4, 5. So 5, here also 1, 2, 3, 4, 5. 5 5s are 25 square units. Unit squares or square units. Now, if you observe this diagram, what will be the idea you are getting? What is the idea you are getting with regard to this right angled triangle ABC? If I sum up the unit squares on AB and BC, on AB you have 9 squares. On BC you have 16 squares. If you add it, you get 25. So that is nothing but the unit squares on the hypotenuse. This is nothing but Pythagoras theorem. So in a right angled triangle, the square on the hypotenuse is equal to sum of the squares on the other two sides. That's all the theorem. In a right angled triangle, the square on the hypotenuse is equal to sum of the squares on the other two sides. Very simple now. Children, many a time when asked to state Pythagoras theorem, they get tongue-tied and sometimes they lose breath also. I don't know why. It's very simple. Very simple. In a right angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Hope I made the statement very clear. And dear children, this is the only theorem. There are so many theorems in mathematics. This is the only theorem which has more than 360 proofs, different types of proofs. Some are numerical like this, some are geometric, some proofs we do by using trigonometry. There are different methods to prove this theorem, and in this class I am going to prove this theorem using the simplest method, simplest geometrical method. Children, now we are going to prove Pythagoras theorem geometrically. So in this proof, we make use of the idea of similarity of triangles. So we are going to prove the theorem making use of the similarity of triangles, which you have already learned. The statement of Pythagoras theorem is like this. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So how to prove this theorem? So you know the steps of proving a theorem. First thing is data are given. What is given in the statement? In a right-angled triangle. That means a right-angled triangle is given. Triangle ABC is right-angled at B. Triangle ABC is right angled at B. That is angle B is equal to 90. That's all given. What to prove? In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Square of the hypotenuse, that is AC square, is equal to sum of the squares AB square plus BC square. This is what you have to prove. Now, I told you earlier that we are going to prove this theorem making use of the idea of similarity of triangles. If you want to make use of the idea of similarity, you need to have at least two triangles, but we have only one triangle. So, to make two triangles, we will do a construction. This is manipulation in the diagram in order to prove the theorem. So the construction is, I am drawing BD perpendicular to AC. So BD is drawn perpendicular to AC, the hypotenuse. So what is the construction? Draw BD perpendicular to AC. So next thing is proof. AC square is equal to AB square plus BC square. So we consider, now totally you have three triangles here. Triangle ADB, triangle BDC and triangle ABC. So we will have to take two triangles. Out of these three triangles, you have to take two triangles. Okay. So we will take triangle ABC and triangle ADB. In triangle ABC and triangle ADB, just consider triangle ABC and triangle ADB. This vertex A is common, let it be some x. Now, angle ABC is right angle, this is 90 degree. Angle ADB is also right angle. So this is 90 degree and this is also 90 degree. One angle is common, the other angle is 90 degrees. So in these two triangles, angle A is common, is equal to angle ADB is equal to 90 degree. Therefore, triangle ABC is similar to triangle ADB. Which is the criteria applied here? You might be knowing that. This is called AA similarity. Just write similarity. That's all. So making use of AA similarity, we have proved that triangle ABC is similar to triangle ADB. Triangle ABC is similar to triangle ADB. So making use of similarity of triangles, AB divided by, see this is AB, here you have AD, is equal to AC divided by AD. We have taken the corresponding sides AB, here AD, AC, here it is again AB. If you cross multiply these two, you get AB into AB is AB square is equal to AC into AD. This is our result 1. Now let us consider triangle BDC and triangle ABC once again. In triangle ABC and triangle BDC, you know, this is ABC, this angle is 90 degree, this is BDC, this angle is 90 degree, and angle C is common. This angle is common, let it be Y. Common angle. Angle ACB is common. Angle ABC is equal to angle BDC is equal to 90 degree. This angle is 90 degree by construction. This is 90 degree because it is a right angled triangle. So again, in these two triangles, triangle ABC and triangle BDC, two angles are correspondingly equal. Therefore, triangle ABC similar to triangle BDC. Similarity. So from this, you want to show that you have to get this side. AB square we have found. Now let us find BC square. So BC is this. Here it is BC. Now one more BC is here. So it is this. So we are taking corresponding sides. Okay. For BC, here it is BC. In the denominator also again one more BC you should get, that is because you want to get BC square. So this BC is taken, here it is this. So this implies divided by BC is equal to AC divided by BC. Implies on squaring you get BC square is equal to AC into BC. So let it be the second statement, second relation. So we have got two relations. One is AB square is equal to AC into AD. The other one is BC square is equal to AC into BC. We will add up these two relations. AB square plus BC square. AB square plus BC square. This is the left hand side of the two relations, relation 1 and 2. We are adding, okay? AB square plus BC square is equal to, in the right hand side what we have here? AC into AD. AC into AD. Here AC into BC. So here AC and AC is common, so take it out. AD plus BC. Now look at this figure. What is AD plus BC? Can anyone tell me? Yes, it is AC itself. So AC into AC is nothing but AC square. That's the proof. AC square is equal to AB square plus BC square. So the proof is over. QED. What is QED? Chord erect demonstrandum. That means that is the proof of the theorem. So we have proved the theorem. Very simple. Very simple. Children, is it clear? I hope you have made it clear. Only few steps and it is very simple to prove Pythagoras theorem. This is the simple. From this theorem, you have got result 1, result 2. These are the very important results. I just highlighted. Result 1, result 2. Very important results to work out problems later on. Children, proof of the theorem is over, but still I will continue to get one more result, the third result. You know that triangle ABC is similar to triangle ADC. Triangle ABC is similar to triangle BDC also. Triangle ABC is similar to triangle ADB. Triangle ABC is also similar to triangle BDC. What is the inference from this? This is similar to this and this is also, things which are equal to the same thing are equal to one another. So these two triangles are similar. Therefore, triangle ADB is similar to triangle BDC. You understand? Here also, in triangle ADB and triangle BDC also, in other way also you can prove it. 90 degree. This angle is, now look here. Sum of this is x plus y. X plus y is 90. So how much is this angle? 90 minus y. This is 90 minus y. You understand? So this plus this is 90 degree. This is x. So how much is this? 90 minus 1. Here you have y, this is 90. How much is this? This is 90 minus x. 90 minus x. Am I right? So that way also you can prove that these two triangles are similar. So what to break our hand? Just make use of this idea. So these two triangles are similar. Therefore, I'll take this BD. Here it is similar, corresponding sides. For BD, this BD, what is the corresponding side BD of this triangle? If you see the size of the triangle and the proportionate length of the sides, in this triangle, this is the second longest side. Here, in this triangle, it is DC. This is the second longest side. So, BD, here it is BC. Now, consider this BD, it is AD, corresponding. So, therefore, BD divided by BC is equal to AD divided by BD. If I cross multiply, what do you get? BD into BD is BD square is equal to AD into DC. This is the third result. This is also very important. Result 1, AD square is equal to AC into AD. Second result is BC square is equal to AC into DC. And third result is BD square is equal to AD into DC. So, if a perpendicular is drawn to the hypotenuse from the right angled vertex, the perpendicular divides the hypotenuse into two parts. Then what is the relation between the perpendicular and the segments or the parts of the hypotenuse? BD square is equal to AD into DC. Very simple now. The square of AB is equal to the hypotenuse into this part. This part, not this part, okay? The square of BC is equal to AC into this part. It's very simple to remember. So these three results are very important on the point of proving problems, working out problems based on Pythagoras theorem. So you should note down result 1, result 2 and result 3. Is it clear? Children, now we will solve a problem, very simple problem, okay, based on Pythagoras theorem. So the problem is as given in the diagram. You have a triangle ABC wherein angle A is 90 degree and triangle within that triangle you have one more triangle that is ABCD, which is also right angle triangle HD. The length of AD is 6 units or 6 centimeter. I will make it centimeter. And CD or DC is 8 centimeter and this BC is 26 centimeter. Find the length of AB. So how to go about? Can anyone tell me? You have two right angle triangles here. For right angle triangle ABC, only one side is given, so you won't be able to find the other two sides. It's not possible. Now in the other right angle triangle, two sides are given. So I hope you got it. You can find AC, the length of the side AC. making use of Pythagoras theorem. In right-angled triangle ADC, AC square is equal to AD square plus CD square or DC square. So this is AD is 6 centimeters or 6 square, and this is 8 square. You know how much is 6 square? Yes, 36. How much is 8 square? 64, right? You add up, you get 100. Therefore, AC is equal to root of 100, everybody knows it, 10 centimeters. Okay. So, now you know AC is 10 centimeters. So, in this right angled triangle, two sides are known. So, you can find the third side. In right angled triangle BAC, you want to find AB's AB, length of AB. So you know BC square is equal to AB square plus AC square. Am I right? Square of the hypotenuse is equal to sum of the squares of the other two sides. This is the hypotenuse. This AB square plus AC square. How much is BC? This is 26. 26 square is equal to AB is what we have to find now, so it's not known, AB square. AC square is 10 centimeters. Okay. Therefore, AB square is equal to 26 square minus 10 square. So 26 plus 10 is 36. 26 minus 10 is 16. A square minus B square is equal to A plus B into A minus B. So multiply. You are good at multiplication. Just do it. 36 into 16. 6 6 are 36. 3 is carried. 6 3s are 18 plus 3, 21. 6 3. 5 76. 5, therefore AB is equal to root of 576. How much it is? So find the square root of 576. Children, the square root of 576 is 24. So the length of AB is 24 centimeters. How's it? So very simple. Only thing you need to know how to find the square root of this given number by factor method. You can easily find it. And one more thing here, what I did is I did not find the square of 26. Instead, I made the identity. You are familiar with the identity. A square minus B square is equal to A plus B into A minus B. 26 plus 10 is 36. 26 minus 10 is 16. So in order to make it easy, so this simplification, this multiplication is very familiar to you. So you won't be going wrong. So I made use of this idea. So 576 and the square root of 576 is 24. So finally we found the length of the required side AB is equal to 24 centimeters. That's all. See in the textbook. You have a very wide and long exercise. Plenty of simple and some complicated problems are also there. So in the next class we will work out some of the problems, and don't wait till then. you please work out the problems given in the exercise. That's all. Wish you all the best. Bye.